Hi all, in this video I am giving an introduction about the approximate methods for the analysis of multi-storied buildings. We know that the construction of high-rise buildings or multi-storied buildings are very common even in the village also. The analysis of frames in multi-storied buildings proves to be very complicated because they have a large number of joints which are not free to move. Also, in the case of multi-story frames, the degree of indeterminacy, degree of indeterminacy we already studied in the previous semester. So, in the case of multi-storied frames, the degree of indeterminacy is very high. So, the solution by the exact methods like slope diffraction method, moment distribution method, Canis method is almost ruled out. So, with the certain assumptions, design engineers always use the approximate methods of analysis for the quick solution. In this module, we are going to study some approximate methods. In this module, we are going to analyze multi-storied frames for vertical loads as well as the lateral loads or horizontal loads. For the analysis of vertical loads, we use substitute frame method, and for the analysis of lateral load or horizontal load, we use portal method or cantilever method. So totally there are three methods that we are going to discuss in this module. Here comes the first question from this module. Why we prefer approximate analysis for multi-story buildings? When we use conventional method or the exact methods for the analysis, then the analysis involves a lot of complication and tedious calculation. To carry out exact analysis is a time consuming task. That's why we are moving for a approximate analysis. And also we can check the answers obtained from the computer aided analysis or computer aided softwares like StatPro, SAP, ETABS, etc. And for design engineers, they have to done a preliminary dimension of building components before exact analysis using these methods. Then what is the advantage of using this approximate method? We can get the faster solution. We'll get the quick solution for the multi-story buildings. Then what is the disadvantage for this method? That is already mentioned that the results are approximate, not exact solution. Approximate methods are particularly useful for the multi-story buildings taller than 3 stories. Here comes our first method for the analysis for vertical loads, that is substitute frame method. This method is used for the analysis of multi-story frames subject to vertical loads only. The major assumption involved in this method is that the moments in the beams of any floor are influenced by loading on that floor alone. Or in other words, the moment transferred from one floor to another floor are negligible, and hence the analysis can be made floor by floor. So we analyze only a part of the frame, and that particular portion of the frame is known as the substitute frame. The process involves the division of multi-storied structure into smaller frames. These subframes are known as the equivalent frame or substitute frame. That's why this method is known as substitute frame method. This subframe or substitute frame are usually analyzed by using moment distribution method using only two cycle moment distribution. Let us consider a G plus 6 frame. We are going to analyze this frame using substitute frame method. As I mentioned earlier, the analysis using substitute frame method can be made floor by floor. For analyzing one floor, we are going to find a substitute frame for that particular floor. Suppose we are going to analyze this particular floor. So first of all, we are going to draw the substitute frame for that particular floor. The substitute frames are formed by the beams at the floor level under consideration, all together with the column above and below with their far ends fixed. The ends of the column are considered to be fixed. These ends are in fixed condition. So we are considering that particular beam in that floor and the columns below and above and below of that particular beam. So that's our substitute frame. Now we are going to analyze that substitute frame for getting maximum span moment, support moment and a column moment. In the multi-story frame, both dead load and live load together constitute the vertical loads. Dead load acts throughout the frame and at all times, but live load may act throughout the frame or on a part of it at a particular time. So for the analysis or for getting maximum moments, various combination of live load are to be considered, because for the same frame the live load position for maximum span moment, support moment and column moment may be different. Now we are going to discuss about the critical live load positions to get various design moments in the beam. First one is the critical live load position for getting maximum positive span moment at at AB or maximum sagging moment at AB. Here is our substitute frame. This is our span AB. For getting maximum span moment, positive span moment, the beam AB should be sagging like this, and the adjacent span should be in a hogging shape, and the alternate span again sagging. This is the influence line diagram for getting maximum positive span moment at a AB. The dead load acts throughout the frame and at all times. For getting maximum sagging at AB or maximum positive moment at AB, the live load should be in the beam AB and again loaded in the alternate span. The adjacent span should be vacant. Now the critical live load position for getting maximum negative span moment in the span BC or maximum hogging moment at the span BC. This is our substitute frame and this is our span BC. For getting maximum negative moment in the midspan of BC, the influence line diagram like this. The influence line diagram in this span BC should be in the upward direction, and adjacent span, and at the adjacent span it should be in downward direction or sagging direction. And the alternate span it will be again in the upward direction or hogging direction. Then the dead load is distributed over all beams. For getting hogging in the span BC, the live load position should be like this. The adjacent span of beam under consideration should be loaded with live load. Here is our third critical live load position, that is live load position for getting maximum support moment. This is our substitute frame. This is support A and this is span AB. For a continuous beam, the support moment will be negative when the midspan is sagging. So for getting maximum negative support moment at a support A, then the adjacent span to the support A should be sagging like this. Look at the position of beam or position of the inference line diagram at the adjacent span to the support A. For getting an inference line diagram like this, then the live load position should be like this. The adjacent span to the particular support under consideration should be loaded with the live load,